So what I have here is a couple of functions. F of x equals the square root of x. G of x equals 2 minus the square root of x. These are both root functions, okay? Square root of x is simply the parent. 2 minus the square root of x. I see that as something shifted and mirrored. All right, and so I'm going to write that up that way a little bit first because I like seeing the domain of these. Move this over into the dead spot. When I look at g of x, I'll do it in red. I actually see it this way. I see it shifted 2 to the right and mirrored, all right? So when I picture these two graphs, f of x in my head and everybody's head should be very quickly to this, right? Where the domain is simply, square root of x, where the domain is simply 0 to infinity, all right? And then the red one, and it might, I'm better at math than you guys, period. No matter what you think. I see this as a graph like, let's see here. Nope. Hang on. Sorry, I went the wrong way. Reflects across the y, right? So there it is. So everybody, do you guys see our domain problem when I start making composites here? We're going to have to be careful. Well, we're going to have to really work through this and think about it because I think that sometimes, but listen, I didn't do f plus g or f minus g, did I? I did composites. If it was f plus g, f minus g, yeah, boom, it's between 0 and 2 and we're done, right? Because it would be the overlapping portions of the domain. But these are not that. So the first thing I want to do is f of g, right? So if I do f of g, and again, this might be overkill, but are we all thinking this at least? Yes. So it's the square root of the square root of 2 minus x. Do you guys all agree? So for the first one, f of g, I see it as 2 minus x, right, on the inside square root of the square root. Last time I checked, that's the fourth root, all right? So the question is, where is that greater than or equal to 0, right? Now we have to consider this function. And I think this function goes from, and this matches up here. Do you guys agree? So this function's domain is negative infinity to 2. Yeah. Because when we build composites, we have to check. This is different than the operations of multiplication, division, addition, subtraction. There is, and I'm going to get rid of this because we knew this in our head. So that's the first one. Now I got to do g of f. G of f is going to be, again, I'm plugging, this one's a little more complicated, so I might just leave it like that. All right? And again, we recognize what? That the inside 2 minus the square root of x has to be greater than 0, right? And if it helps you see the domain, I'll write this out. This has to be greater than or equal to 0. You guys agree? And the inside of that x has to be positive. All right? So I'm pretty sure 0 will work in here, right? 0 is our first one, and it can go all the way to 4. So x is going to be an element. 0, 2, 4. Boom. That's g of f. Now, I'll do g of g. So g of g, kind of a broccoli one here, is 2 minus the square root of 2 minus x. The nice part is we've already figured out, all right, we've already figured out that the domain of g of x is this, up here. You guys agree? So when I see the domain here, I know it can go from negative 3 to negative 2, but I know that my range output has to stay. I know that this expression has to be greater than or equal to 0. All right? That this is what it has to be. So we start having to go through this, right? And so I see -2. I like to find the 0 first. You guys see how if I plug -2 in here, I get 0? So that's kind of my left bound. The question is, how far to the right can I go? Well, this has to stay positive also. You guys agree? Or 0? So I think the furthest to the right I can go is +2. So the domain on this one, coming all the way back, because I really don't want to go through and solve this. I mean, it is a pre-calculus exercise. You guys are all capable of it. But I think in these simple cases, it's easier to guess and check. And that's what I just did, right? I guessed and checked my way through the possible solutions. Last one, f of f. All right? Everybody, I suppose I could write it out because it's fun to write. It's just x to the 4th. All right? It's still 0 to infinity. You guys all agree? This is the same as the root function, x to the half power, but it just goes in here. Everybody, this can't be lost on us, that this is substantially different than if I asked you to do f plus g. Do we all agree? Where f plus g up here would just be this function, all right? And the domain of this one would just be the overlap, which was what Riley was saying. We don't even have to really search. We go up and we find the overlap of these two, right? Substantially different than the composite functions we made, all right? Composite functions and all our rules.